Hello, algebra students. We're looking at 4.7, transforming formulas. This is really nothing totally new. It's really all your kind of solving equation stuff, all your algebra skills put together here. So we're going to take a look at that and make sure you're bringing any questions you have to your algebra teacher. One of the things we want to keep in mind when we're transforming formulas and kind of moving things around in a formula to find what we need is that we want to put our answers in set braces when we're finished. So when you find your solution, I want to put that into set braces, and that we need to state our restrictions. So sometimes when we rearrange formulas, we run across things that will work, but then there are exceptions to that, and we need to state those exceptions or restrictions. So in the next several examples, we are asked to solve each equation for x. Now you're not going to find a number answer here because we don't have numbers or constants for the variables. So you just want to think about getting that x by itself on one side of the equal sign. So if all the other letters were numbers, how could you get that x by itself? And you follow those same equation solving rules. So in example 1, if b and a were constant values, how would you get the x by itself? Well, you would divide by whatever that a value is to get the x by itself. So you're still going to do that. Or another method is that you could multiply by the reciprocal. And so what happens is those a's will cancel and you get x is equal to b over a. And so our solution set is b over a. Now, here is the restriction part. If we're dividing by a as our solution, then a cannot be 0. So we need to state that a cannot be 0 because we can't divide by 0. So when we're looking at finding these solutions, our restrictions are based on the fact that we can't divide by 0. So keep in mind, no dividing by 0. So basically dividing by 0 would be like destroying the world. So again, restrictions are based on the fact that you cannot divide by 0. So let's take a look at example 2. How would you get the x by itself? Hopefully you would subtract a from both sides or add the opposite of a. And so you get the expression b minus a is equal to x. And so our solution set is b minus a. Now because we're not dividing there are no restrictions. And while we're practicing this skill, if there are no restrictions, we would like you to write that so that we know you're going through the thought process of looking for restrictions. All right, so let's look at our next example, a little more complicated. So if we've got more than one term, we want to separate, get the term with the variable we're trying to isolate, get that term isolated first. So since I have two terms here, and this ax term is the term with my variable I'm trying to isolate, I want to get that by itself. So I want to get rid of the negative b, or the opposite of b. So I'm going to add b to both sides. That gives me c plus b is equal to a times x. And then now I want to get the x isolated, and so to get the x by itself, I would divide both sides by a. Those are going to cancel, and I end up with x is equal to c plus b all over a. So my solution set is C anything where C plus B is over A. Except I'm dividing there by A. And so my restrictions, because I can't divide by 0, is that that is the solution set except that A cannot equal 0. So I need to make sure that I put in that restriction. In the next example, I'm dividing x by b squared, but I want the x by itself. So you can approach this by either multiplying both sides by b squared, okay, and then those will cancel, and you get a b squared is equal to x. So that indicates your solution set. So our solution set is simply that x is equal to ab squared. And because we're not dividing in that case, we can say that there are no restrictions. In this next example, I'm trying to solve for n. So it's the n I'm trying to get by itself. It can be really tempting to want to distribute here, but if we think that through, that would be putting an n with 2 terms instead of just 1. And so we don't want to do that because it will kind of give us more to deal with. And so I really just want to start by getting the n to have no denominator. So I have to think about how can I get rid of that 2 in the denominator? Well, I can do that by using MLE and multiplying both sides of the equation by 2. That's going to give me 2s is equal to n times a plus l. All right, so again, I don't want to distribute that n because the n is what I'm trying to isolate, so I don't want to share it with any more terms than I have to. So how can I get that n to be by itself? Well, what I need to get rid of is this factor times n of a plus l. And so I would divide by a plus l. And of course, I have to do that on both sides. So those will cancel. So my solution ends up being 2s over a plus l is equal to n. So that is my solution set. My solution set is 2s over a plus l. It has division, so it has restrictions. What will the restrictions be? A plus L cannot equal 0. In the next example, I'm trying to isolate W. Now W is inside the parentheses, so I want to make sure I can get that out of parentheses. And there's a couple different ways I can approach that. I can either distribute the 2, or, which would eliminate the parentheses, but of course that would share the 2 with the W, or I can divide both sides by 2. I'm going to start by dividing both sides by 2, so I don't have to put, because if I distribute, then I'm sharing the 2 with the W, and that's just more to get rid of. So if I divide both sides by 2, I get P over 2 is equal to L plus W. I don't have the W by itself yet, but I can eliminate the L by subtracting. So I can say minus L minus L. And so I get P over 2 minus L is equal to W. And I've gotten the W by itself, and that's my aim. So my solution set is P over 2 minus L Now, I'm dividing here, but I'm dividing by 2, and 2 already doesn't equal 0, so I don't have to worry about that. So there are no restrictions. So in example 7, we're solving the following for a. And as you can see, we're getting a little more complicated here. We have more than one a in the equation. So our goal would be to get those a's together on one side. But if we have that what we're trying to get rid of in a denominator, it's always a good idea to get it out of the denominator first. So how can I get that a out of the denominator? Well, I would need to multiply both sides by the denominator to eliminate the denominator. So I'm going to multiply both sides by a plus b. These would cancel. That's going to give me r times a plus b equal to ab. Now, I definitely got rid of the a in the denominator, but I need to try and get the a's to the same side. Now, in order to do that without putting it back into the denominator, I need to distribute the r. So I get ra plus rb. Now that does share the a with something else that I would need to get rid of, but it's going to allow me to get the a terms on the one side of the equation. To do that, I'm going to subtract ra, or that term, from both sides. That gives me rb is equal to ab minus ra. So now my a's are on the same side of the equation, and I can use the reverse distributive to pull that a out of those terms. And so that gives me rb is equal to a times b minus r. So I'm using distributive in reverse there to pull out that common factor of a, which now leaves the a almost by itself. To finish getting it by itself, or isolating it, I just need to divide both sides by b minus r. So my solution set is rb over b minus r. Now think about the restrictions. B minus r cannot equal 0. Now this process sometimes requires some trial and error. So if you start off and you feel like you're headed in the wrong direction, don't be afraid to try again with something new to start. If you have any questions, make sure you're bringing them to your algebra teacher.